every process. Okay, the side live streaming went off. Sorry about that. So when you make it during the system call, the kernel allocates time for every process. Not so. Now, again, during the process, that time sharing is figured out, and the CPU is able to know that okay, this one is this job is going to take 10 days. So it should probably wait, right? You should probably wait until I execute the process. Loni is an expert in this stuff. Um, yeah, Loni, you can tell us more about shortest job first, those stuff. I mean, if you want to, I've forgotten most of it, but I can recall that there's just those time sharing stuff that the CPU can figure out that okay, this job is going to take this amount of time. I should start with the jobs that I should execute the jobs that will not take a lot of time, and then deal with the ones that will take a lot of time later. And there are other ways of time sharing, other stuff. I can remember just one honestly right now. I don't remember the other ones. Unless Loni is generous to tell us if she too remembers. But yep, that kind of thing. So that's what is called process scheduler. So the kernel can act, yeah, as the process scheduler. Not so. And we can visualize this. Oh, I ran this command. Oh, wait. Yes, I ran this command before you guys joined because I was trying to refresh my memory. Right. And this is very nice. I like it when it gives me a lot of output like this. PID means process ID. PPID, really, I don't know what PPID means. This is the command, right? Means that this is the program that is making a system call. Ah, okay, we'll jump this two. I don't know about them. And then we have this one, the CPU, the percentage of the CPU. So this particular process here with this ID is using 93% of my CPU. Who the hell are they? Okay. So obviously, thank you guys for making me run this and notice and looking because I ran it but I did not look. But yeah, it's consuming a lot of my CPU. It's not supposed to be the case, right? And I have a lot of stuff there. I also have Chrome, which is the process that is helping me talk to you right now, right? And it is consuming, yeah, it's because I have four cron, how do they call these things? Not the tabs, window, four cron windows open, and each of them are running more than 8 tabs. That's why this one is understandable. And I have this Wazoo system check, which means that if you try to hack my PC, I'm going to know because I have this nigger installed, for example. I don't know much. So this one is because our company is putting this K3S server that is running. I thought I killed it. So the point is that from here, if I expect a particular program to be running and it is not running when I run this command, then I know that there is the system call for that program is not even made right. This is Discord so that I can see la la la. I have Teams for my messages, and I have this guy, I have this guy, I have this guy because I don't want people to hack me. And Slack. Yeah, literally everything that is making a system call, everything that is trying to tell the hardware system to execute any task. These are them. And their time scheduling is not, wait, I can try to interpret it. Oh, this means this is a parent process. The parent process ID is parent number one. Who is parent number one is a demon. So looks like this is an important system call, but why is it taking a lot of space? I'll need to figure it out. This is a parent program. So who is this nigga? I can look at it from here, that kind of stuff. But anyways, um, this is literally what you do to figure things out, right? Who has not understood what I'm doing here? Who has not
So,
understood?
I didn't understand the CPU percentage very well. Like, is it like that the command, like, for example, the suricata means it takes 93.3%. Is it like
Mm-hmm.
it takes much of your CPU space or computer space?
Mm-hmm. What? 93? No,
Yes,
it
the first
means
one.
it means that the CPU the CPU capacity, 93% of the CPU capacity has been taken only to execute this command.
Ah,
So,
okay.
yes, 93% of the
And
CPU capacity.
can it be configured?
Well, we can look at that. Oh, now I just noticed this and I realized that this is called niceness and this is called priority. There's a Linux command called nice. Do you guys know about it? Nice.
No, sir. No, no, I don't know about it.
So if I take a process ID, for example, let's take the first one, not so. So I'm going to do this first to make our life simple. This is a good, important topic for us. What the heck? Topic for us to talk about. Wonderful. If I do nice, la la la. Okay. It's checking from the file or directory. It's not taking the process ID. I've forgotten how to use this nice. So I'm going to say nice minus help. Good. Run is a command. Okay, it takes the command. Wonderful. With adjusted niceness, which affects the process scheduling, right? So, if I want this stuff to stop taking, yes, now this answers your question. Very good. Thank you for asking that because now it led me to think about this nice stuff. So it affects the process scheduling. So if I take that command, with no command, it prints the current niceness, the value range between, so -0, the most favorite to the process, and 19, the least favorite to the process. Okay. Okay, this because there's niceness, there's priority, right? Anyways, I guess we'll talk about this sometime. I hope. But this is what happens if you want if you are executing a task. Let's run this thing again so that I can explain. Wonderful. So When you come here, not so, you have 10 is greater than 0. Let's go back so that nice help. Minus 10 is the most favorite. So 0, a job that has a niceness of 0 will be executed before a job that has a niceness of 10. Okay, that's what it means. Wonderful. So let's go back. Let's pay attention to these nice values. We only have 0 and 10. Not so. It means that when this thing is going for scheduling, not so. All these other ones, these ones and these ones are scheduled to run first before this one. That's literally what it means. Honestly, I need to remind myself about what this priority means. I've forgotten. But yeah, that's what niceness means. Right. Niceness. So if I want this job to be executed before all of these jobs, all I need to do is change the niceness, which I'm not going to do. I'll copy the command, and I don't even know how to put the niceness. I can go see it again here. So what do they say? Adjust minus n to adjust the niceness. No, right. So you put minus n and then the niceness there. Wonderful. So if you don't put minus n, the default is 10. Oh, so the default niceness for any program is 10. That's why. So we have this. We have that program. We put minus n. And then if we put minus 1, for example, it starts from minus 20. So any program, if you want to make the program the most favorite to run, then you give it a niceness of this, for example. And then the CPU will be scheduled to run that program first before any other program. Literally, that's what it means. Who am I confusing? Anybody's confused? Okay. I take it that that's okay, that we are all doing just fine. That's wonderful. So I'll go back to my terminal. So that's what that means. So the next thing that the kernel does is to manage the memory. And if you want to see all the allocation of memory to processes, then it's a very good one, right? Because it's found here and it's called mem info. Thank you. Nope. So why did he do that? Wow, that was strange. Okay, wonderful. So if you want to see all the memory allocation that is being handled by the kernel, well, here you have it, right? Swap, swap total, la 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 la, active files, inactive files, active anon. I don't know what an anon is.
So my this is really going off on Cameroon.
Mm-hmm. So all of these things, this is also what the kernel handles, like memory allocation. Anybody confused so far?
So
Yes.
please,
So
what was the previous command to run to see the previous thing? Those red stuff.
red stuff.
Yes,
Do you mean this?
yes, this one.
This one?
Yes, sir.
Yeah. This is the command. I mean, for you, it will be cat. Why does it keep doing this? Right. So this is a command.
Okay,
ME.
okay, ME.
MI.
Okay,
Yes.
Wonderful. So that
okay,
is how the kernel has allocated memory. And if you want to see it very high level of the allocation of memory by the kernel, then this is what you're going to see, right? You have here in human readable form, I have 61 gigabyte of RAM. I've used 39 and I have 2 gigabyte free. I have 19 as cache, and then this one is the one that is shared, and then this one is the one that is available. What does that mean? What's the difference between free and available? You guys know. Okay, that's something to investigate. That's never been important to me, so never done. I've never had to check. I guess I have to check. But if you guys know, then you guys can let me know what it means, right? So the next thing that the kernel is in charge of doing is to allocate input-output subsystem, literally, which is what stands out. So it manages like the blocks and they call it character devices, right? So the abstract hardware through device drivers. I always prefer that link, and I've not looked at it. I always keep saying that I'll look at it, but I've never looked at it. But yes, I'll call them drivers, device drivers. So if you literally you want to see how that has been done, the device drivers, then you can, hi, hello. So these are the things that I used to communicate with with different parts of the hardware system, right? And you can see the kind of permissions that I have there. So these are blocks, and straight away another blocks is for storage. I don't know what this one is, but bus, you guys know about bus, right? You guys know about a bus. Helpful. Okay, you guys know that's why you're quiet. That's nice. So there are CPUs, there is disk. Okay, now what's the difference between disks and blocks? Okay, never been. Again, I've not never had the chance to look at these things in depth because really they have not been important to me. This one is important. I've looked at it. System Z journal. Exactly. If your system, what the heck? Um, if you're having troubles at boot time, I know that this is the one of the files to configure to look into. So I know about
okay,
that one.
sir.
Yes. And the standard error. If you run a command and that command does not make sense, which means that it is something that the hardware will not be able to interpret. Who tells you that there is an error? It is this guy. If you have a command which is an output that input that requires a system call, who says that that is supposed to be a system call? This man. If your program is expecting an output, where does it get it from? This guy. So, yep. So this is how they have managed blocks and character devices in literally character devices. When you press J, why do you see J? Right? Because there are devices for that, right? And that kind of stuff.
Also,
So it may not be explaining well, but the point. The next thing that the kernel will do is that it manages a virtual file system, right? So really, I'm not trying to spoil my PC, so I'll just say file systems. If I do that, wonderful. So these are the virtual file systems. Do you guys know about these particular ones? Because you should know. Trust me. If you want to be using Linux, you have to know about these ones. This one, this two, this three, and this one. Very, very useful. You want to know about this one. And which one again? Temp folder. This one. This is actually the one. This one. This one. Well, but these ones are advanced. So probably when you're doing Docker or those kind of things, important for you to know about this one, these two, right? And yeah, but this is basic. You need to understand this one and this one. Unfortunately, I'm not talking about any of them today. So, yep, but that's file system stuff for you that Linux is handling. And there's one that I'm looking for. It's called X. Starts with X. Do I have it? I don't have it. Oh. Okay, my system does not run on that one. Wonderful. Okay. So this is showing you the different types of file systems that are supported there. Run it again. The different types of file systems that are supported. X, extended for, I'm sure that's what it means. Forgotten. But X2, X3, X4, right? This is the latest technology. This one is very old. This one is also old or older than this one, that kind of stuff, right? And is this confusing for anybody?
Yes, it's
yes,
Yes.
yes, sir. It's confusing. Normally,
Okay, then that's fine. Let's take a break so that I can use the restroom and then we'll come back. Can we come back at 1:15? Yannick, is that okay if we come back at 1:15? Is Yannick still in the call or is learning? Okay, 1:15 we'll be back, guys. Take care. Eat chocolate, drink water, come back.